Hi there, Rory again, here to do a final electrical sign-off for power integrity with hyperlinks. We will do a DC drop simulation on the entire design, now that it is complete, to make sure that there aren't any new power problems, and to verify everything is in order before fabrication. Remember, we had a failure before on the PE1v2 plane where we exceeded our max current density. Circuit performance is greatly dependent on the design current level, and since we're using 4 DDR4 DRAMs, we want to make sure that they are getting enough voltage and current to do their job. Also, if too much current is focused in one area, like where we exceeded the max current density, it can cause excess heat and cause possible metal failures on the PCB. Now that the simulation is finished, the report shows some good news. We have passed all of our checks and the board is complete. Let's take a look at what the final DDR4 power plane looks like. First, we look at the DC drop voltage. Don't let the red here scare you. This is just a color scaling, and you can see down here in the bottom left our actual measured voltage drop. The different colors show different values, red meaning lesser voltage than blue, and if you change the scaling in the top right, you could get them all to match, since they're so close, just around 5 millivolts apart. Not a big deal, and well within our tolerance that we have checked for, which is why the max voltage drop check passed. Next, I'll take a look at the current density again. Notice that there's some current draw here, but nothing that exceeds our requirement for the board, and nothing that caused a failure. Of course, there will be some more current draw in some spots. Looks like our PCB hardware teammates fixed that thermal tie issue from before, and now we no longer have a current density failure. This check now passes our electrical sign-off. Another interesting thing you can do with the power scope and hyperlinks is to turn on the current vectors. You can see how the current flows in this power plane. Here we can see the current flows as expected from the power supply. The bigger the arrows, the more current there is in that area. And some areas don't have great current draw, but that's not necessarily a problem. It just depends on what is in the layout. Let's go take a look since we're validating the layout. Here are the DDR4 DRAMs on the top side, and their power plane that we just simulated with DC drop is on this layer. We can swap the view from hyperlinks to layout easily, and for these 4 DRAMs, you can see the most current draw and flow is here, which is exactly what we designed for, as we want to power these DRAMs sufficiently. Since the DC drop simulation passes, we are one step closer to bringing our PCB to fabrication.